The way we do this, and this is a second aspect of the work that I do, aside from working with the phenomenological evidence that we have of these rapid changes in climate that occurred from last glacial maximum until the modern interval, one of the tools that we are able to make use of in the reconstruction of these climate regimes have to do with modern supercomputer technology. So the first goal in doing a climate reconstruction for Solutrean time is to determine where the massive ice sheets existed in the northern hemisphere and how high they were, what the topography of these ice sheets was, because the topography of these ice sheets and the fact that they are highly reflective of incoming solar radiation has a huge impact on the climate which actually is characteristic of this interval of time. So I've developed techniques which allow me to determine where the ice was and how thick it was, and methods which allow me to determine what sea level history was like through this entire range of time. Because the depth of the ocean and its variations with time, particularly the low stand of the sea, which was characteristic of full glacial conditions, has a very large impact on the nature of the ocean circulation that was characteristic of this ancient climate regime. So the methods that I have developed determine not only where the ice was, how high it stood above sea level at that time, how deep the oceans were all over the surface of the Earth at that time, and this information is input into modern coupled atmosphere-ocean models of climate behavior. When these boundary conditions are input into such models, we're able to compute really rather precisely what the characteristics were of these ancient climate conditions. We're able to determine by how much was temperature colder, for example, on the Iberian Peninsula between 20 and 25,000 years ago. We're able to determine, more importantly, where the sea ice was in this interval of time, how far to the south it extended. And the work that I've done demonstrates that, in fact, the southern edge of the sea ice at this time of last glacial maximum reached as far south as the southern edge of the Bay of Biscay, right into the beginning of the Iberian Peninsula. And this is an extremely interesting fact because our ancestors, should they have crossed the North Atlantic to the Americas in this range of time, would have been located on what was then precisely the edge of the sea ice boundary during winter. During summertime, of course, every year, the sea ice boundary peeled back to the north, far to the north, in fact, until it extended almost to the west coast of Norway. Then in the next winter, it would move very, very rapidly to the south again reaching the southern edge of the Bay of Biscay, and continuing to execute this cycle of sea ice variations as a function of time throughout the period of glacial maximum cold. So this is the nature of the environment which our ancestors would have had to face if they had chosen to make this trip from the west coast of Europe, from the Iberian Peninsula, to the east coast of the Americas.